Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-455 Section 6380 course for the summer 2021 semester. This is the CCNP ENCORv version 8 course curriculum from the Cisco Networking Academy. And in this supplemental packet tracer tutorial and activity, we're going to be looking at a number of specific use cases for the switch virtual interface. There have been a number of questions this week from a few learners, and I want to make sure that I provide some clarity around the SVI, what it is, and in which use cases would it apply. And so let's go ahead and jump into this packet tracer activity that I've put together here. You can see that all of the switches down here at the access layer, these are layer 2 only switches. The 2960, as indicated by the 2, which is that leading numeral digit here in 2960, indicates it's a layer 2 device. Now, there are some advanced iOS options that you can do on 2960 XRs where you can get a routing image, but we're going to be talking about just a basic layer 2 2960 device. Now here in our distribution layer, or we could have a collapsed core with our distribution and core layer here on this multi-layer switch. Now remember, a multi-layer switch is really just a router that has a whole bunch of ports. And we're going to talk about the advantages and the disadvantages of having multi-layer switches as opposed to a router, which you see up here, router number 1, functioning in your distribution or your core layer. All right, so let's go ahead and start out with the layer 2 device. Now remember, the switch virtual interface is not a physical interface that resides on the device. The V in the middle, virtual, means that it runs in software on the device. It's very similar. Think about a loopback address. So we can create a loopback interface, or I should say loopback interface. We can create a loopback interface and assign an address to that loopback interface, but that loopback doesn't physically exist on the switch or on the router. It just runs in software. And the switch virtual interface, in that respect, that it's virtual and that it runs in software, is similar to the loopback interface. So why would we use an SVI in a layer 2 switching context? And let's address it from a layer 2 perspective down here. So how would I manage the device, or how would I remotely log into the device? In other words, using in-band management, meaning in the network. So think about it like that. In-band management means my management traffic is in the network. So when I'm SSHing to the device, or I'm telnetting to the device, that is considered in-band, right? It's in there with the rest of the network traffic. When we first take the switch out of the box, there are no IP addresses on the switch. We can't really configure it if we just plug into one of the ports, Fast Ethernet 1 or 2. Now, one way that we could configure the device is by using a console cable, right? So we'll say RS-232 and we'll bring it up here to the console port. And so that's what that blue, or that Cisco blue rollover cable, sometimes you'll hear it referred to as a rollover cable, that will allow me to manage the device. Now, this would be considered out of band because it's not in with the rest of the network traffic, right? I'm plugging into a physical port, a console port on the back of the switch. And so that's typically how, when you take the switch out of the box, you actually initially configure the device and you set it up so that you can then remotely manage the device via telnet or SSH, and you can perform in-band management. And so on a layer 2 switch, that is what the SVI is primarily used for management, remote management, in-band connectivity. So let's click on the access layer switch 1. Again, this is a pure layer 2 switch. One way to quickly check that is what happens if I try to say IP routing, right? IP routing is a command that on multi-layer switches will enable inter-VLAN routing. You'll see I don't have that command here. We know that this is a layer 2 switch. You could also say show version and see that we're running the LAN base iOS image. In fact, this is an older 12.2 image, really old. So again, I can use the console cable to plug into the console port on the back of the switch and do an initial configuration. And one of the things that you would set up is a switch virtual interface because it's all about managing the device. And so let's do that. So right now, everybody, or I should say all ports on all of these switches are in VLAN 1. So the first thing that we would do is we would come in here and let's create VLAN 10. And we're going to name that VLAN HR, right? Now, we're just going to go ahead and leave it like that for now. Now, if I want the HR PC, this PCA, to be able to manage this switch remotely, then I would create an SVI, and that SVI would be for interface VLAN 99. Excuse me, VLAN 10 for the HR VLAN. However, this is a common mistake that I see a lot, is that individuals will configure the layer 2 switch, and for every VLAN that is configured on that switch, they will create a switch virtual interface, which is typically not something you would want to do unless you're trying to allow any device in or plugged into that switch to remotely manage that device. Because when I create the SVI, the switch virtual interface, if I create it on this switch right here and I make it for interface VLAN 10, then all of the HR PCs that are in VLAN 10 can theoretically attempt to connect to the switch. Now, they would need to know the username, they would need to know the password, but these are things that they might be able to figure out one way or another, and you probably don't want that, right? What you really are looking for is you're looking for a management VLAN, like a VLAN 99, right? Like we have here in the center. And that has your management PC. So in order to manage these layer 2 switches, you would have to get onto the management PC, right? Now, again, I'm going to show you creating a switch virtual interface for each of these VLANs, right? So that we have some repetition here. But ideally, you have a management device in a management VLAN, and that is the only device and the only SVI that you have created on these 3 switches. It would be for VLAN 99. All right, so let's just do an example here. If we wanted the HR PC to be able to manage the switch, I would say interface VLAN 10. That does not create the VLAN, that is creating the switch virtual interface. Now I put an IP address on here. We'll say IP address in VLAN 10 is just 192.168.10. So we'll say 192.168.10.150, and we'll make it a /24. And we've, we typically don't need to say no shut, but we'll go ahead and say no shut. So now we've got the switch virtual interface connected. So let's try to ping. And the ping is not going to work, right? But let's think through why this is the case. 150. And so here I am on PCA, and PCA has an IP address. The IP address is 192.168.10.10, but we can't ping the ALSW or ALSW01 switch right here. And the reason for that is that we haven't placed the port into which the PC is connected. If I say do show IP interface brief, that fast Ethernet 01, that port has not been assigned to the correct VLAN. So let's get into interface fast Ethernet 01. Let's say switch port mode access. We're going to make it a static access port. Switch port access VLAN 10, because right now all the ports are in VLAN 1. Now you can see that interface VLAN 10 has changed its status to up because now there is a port on the switch that is in the VLAN that the switch virtual interface was created for. So now when we try to ping the 192.168.10.150, we might have an ARP timeout there, the request timeout because of an ARP process. But now, excuse me, you can see that we have connectivity to that switch virtual interface. And that's great, right? So now if I had a username configured, and to do that, we would just simply exit out of here, and I could say username admin, and we'll say secret admin, and then we'll go to line we'll go to line VTY 0 to 15, and we'll say login local, right? And then let's go ahead and say transport input SSH, meaning I'm only on this switch here, I'm only going to accept inbound SSH connections. And so let's come back to PC and let's see if this works. So I would say SSH minus L, that is not a 1, that is an L, admin 192.168.10.150. So I'm using the switch virtual interface IP address that I created in the VLAN where the HRPC sits. And we've got connection closed by foreign host. Hold on one second here. And let's say do show run. Let me check the login local. We've got the transport input SSH. And so let me double check the username admin secret. So we should be good. Oops, sorry. We should be good to go here. Let me make sure. And so I'm missing something on the VTY lines. And what am I missing here? And it's not the privilege. Oh, I have to generate the crypto keys. I apologize. So in addition to creating the user account, we need to create the crypto. I'm sitting here thinking, look, wait a second, this is correct. And then it's like, correct. So we need an IP domain name, right? So let's go ahead and say IP domain name, and we'll say ccie.com. And then let's go ahead and say crypto key generate RSA, and we'll do 1024. And now, and let's go ahead and say IPSSH version 2, right? 1.99 is susceptible to a number of exploits. So now it will work. So the password was admin, and as you can see, now I can remotely manage the switch. And so on layer 2 switches, this is the use case for the switch virtual interface. It's to allow me to remotely perform in-band management via Telnet or SSH, and when using SSH, make sure you generate that crypto key, so that I can manage the device remotely. Now, I can only manage that device remotely in VLAN 10 at this time, right? Because that's the only SVI that we've created. A common misunderstanding is that the SVI on a layer 2 switch is your default gateway, or that it is somehow providing you routing functionality for your transit traffic coming from the PCs, and that is not the case. On a layer 2 switch, the SVI is remote management, right? That is what you're using it for, because you can't do Inter-VLAN routing on a layer 2 switch. Right? That's sort of like an oxymoron. A layer 2 switch cannot do layer 3 routing for you. All right. So that's the use case there. Again, over here, if we wanted to do the same thing, I could come into privilege exec, into global config, and then say VLAN 99, and I'll name it, it'll say MGMT. And then I'd say interface VLAN 99. We'll put an IP address 192.168.99. .150, and we'll make it a /24, whoops, just like the rest of the devices are going to have for their SVI. And then I would go into interface fast Ethernet 01, and I would say switch port mode access, make it a static access port, switch port access VLAN 99. And then we'll come over here and we'll hit the fast forward arrow to get the spanning tree, the spanning tree piece done. And so now if I was to go through those same steps, right, create the IP domain name, make it ccie.com, and then say crypto key generate RSA, and then we'll say 1024. And if I was to go into the VTY lines, I could then create the ability to remotely manage the switch from PCB. So let's see, do I have connectivity here? So 192.168.99.150. And after an initial timeout, we should have connectivity through to the switch, because again, we're directly connected to the switch. And so let's do the same thing over here one more time. And again, remember, the SVIs on layer 2 switches are not there to serve as default gateways. They're not there to route transit traffic. And I'm stressing that, and I'm going to come back to it when we talk about the IP default gateway. All right. So we'll say VLAN 20, name is engineering, and then we'll say interface VLAN 20. Now the interface VLAN 20, that is your switch virtual interface. We'll put our IP address on here, 192.168.20.150. And now we have an interface, a switch virtual interface that we could use if we were on PCC. And we'll say switch port mode access. I'll even throw a spanning tree port fast, see if that speeds things up here. And then switch port access VLAN 20. And you can see the switch virtual interface, as soon as I put a port on the switch into the VLAN that the switch virtual interface belongs to, the switch virtual interface comes up. Up until that point, we would not see that. All right, so we've got 3 SVIs created here, one for each of the VLANs, the engineering VLAN, the management VLAN, and the HR VLAN. Again, remember, typically what you'll see is that all of these would have an SVI in VLAN 99. And that would be our management VLAN. But in some smaller shops, you can't get away with that, or for whatever reason. So again, I'm just showing you how to do it if PCA was plugged into the switch and I wanted to remotely get to the switch. Maybe I'm not close enough to plug the console cable in. All right, so that is the use case for the switch virtual interface on a layer 2 device. Now, there's another very important concept here, and that is when you're remotely managing the device, remember, the switch is just like a PC in the sense that it is a device on the network. And that if I'm going to SSH or Telnet to the switch, I need to have a default gateway for the switch. And so this is sort of the next point that causes a lot of confusion with learners, is when they say IP default gateway 192.168.10.254, and we don't know where that is yet, but that's going to be an SVI up here on this multi-layer switch. So that would be the default gateway. That is also the default gateway that the PCs are pointing to. And it's a little easier to look at it here, right? The PCs are not pointing to the switch virtual interface on the layer 2 switch. They're going to be pointing to the SVI, the switch virtual interface, on the layer 3 multi-layer switch. Because the multi-layer switch can route the traffic. It can move the traffic along. That's why you don't see in this field right here 150. Because that is not going to work. The layer 2 switch is incapable of routing the traffic for me. So I wouldn't send it to the switch, the layer 2 switch. I want it to go to the layer 3 capable switch, that multi-layer switch that we have up top there. And so when you set this IP default gateway statement, this statement applies to the control plane traffic, or traffic generated by the switch itself. In other words, if I'm on the switch like I am right now, I can SSH from the switch to another switch. I can telnet from this switch to another switch. And so this default gateway statement right here, I want you to think of it as being similar to and serving the same purpose as the default gateway statement on the PC. In other words, for traffic that the switch is generating itself, if it is telnetting, if it is pinging, that is traffic the switch is generating. That is not transit traffic. Remember, transit traffic is traffic that is simply passing through the switch. And that is not what that IP default gateway statement is for. So transit traffic would be if the PC is trying to get to that PC, or it's trying to get to this switch, or it's trying to get to that router. That traffic would be transiting, passing through the switch. The IP default gateway statement is not for that traffic. And therefore, this statement has nothing to do with the routing of transit traffic, traffic that's passing through the switch. What it does do, just like the default gateway statement on the PC, it does for the switch if we are pinging from the switch, because I can ping from this switch. I can say ping 192.168.10.10. I can ping PCA. Why not? Right? Now, if I'm pinging a device that is not on the network that the switch knows about and has an SVI for, it's going to use that as the default gateway. In other words, we just get it here to the multi-layer switch. The multi-layer switch can then route the traffic. That's the entire premise behind the multi-layer switch. All right, so now let's take a look at this multi-layer switcher. And you can see we've got these 3 connections, one coming from each of these switches down here. Now, what we could do is we have 2 approaches we can take here, very similar to when we're working with the router on a stick. I could make these both access ports in VLAN 10 so that only VLAN 10 traffic transits that link, or I could make it a trunk link, right, allowing all VLANs to transit across those links, and that would work as well. So it all comes down to use case. Do I have multiple VLANs hanging and configured on all these switches? No, I only have a single VLAN configured, right? So what we would do is, and again, I'm just going to focus here on this, on ALSW01. Let's get into global config. And if I'm not mistaken, it is do show IP interface brief. I think it's gig 01. So let's get into interface gigabit Ethernet 01. And let's say switch port mode access, switch port access VLAN 10. Oops, sorry. VLAN 10. Because VLAN 10 is all I have configured over here. Now, if over on this switch, I had a port, I had VLAN 20 and VLAN 30 and VLAN 40, we would make this a trunk port, right? But since it's only VLAN 10 here, we're just going to make this an access port to VLAN 10. Now, we need to do the same thing on the multi-layer switch, but we'll do that in just 1 second. Let's come back over here. And this is port, and you know what I do not know? I think maybe, is it Fast Ethernet 024? Okay, it is. All right. So we're going to get into interface Fast Ethernet 024. We're already in there, just making sure here. And we're going to say switch port mode access, and then switch port access VLAN 99. And I'll even throw the spanning tree port fast on here. And again, with Packet Tracer 8.0, port fast, for some reason, is not functioning properly. It's leaving the port as the orange dot, so you hit the fast forward arrow, and that'll fix that. All right. So we've got this native VLAN mismatch, and we'll have to figure out what's going on up here, because it looks like it thinks that the link up here on Fast Ethernet 024 is a trunk link, but we'll take a look at that in a second. And then over here, what I could do is we'll come in here and I say do show IP interface brief, and let's take a look, and it's going to be interface gigabit Ethernet 02. We'll say switch port mode access, spanning tree port fast, and then switch port access VLAN 20, right? So we're basically dedicating each of these links on these switches up to the multi-layer switch to an individual VLAN. All right, so now on the multi-layer switch, you can see that it thinks that these are all, oops, sorry, we didn't want that. It thinks that these are all trunk ports. Oops, conf T, we'll say no IP domain lookup, and line con 0, logging synchronous. All right, So if I say do show interface trunk, you'll notice we don't show that we don't show any trunk links, but we've got this native VLAN mismatch here. Because do show switch port, or do show interface, we'll say fast Ethernet 024 switch port. You can see that the operational mode is static access. I apologize for saying it was thinking. I thought it might be, they might be dynamic desirable up here, and then it might be, excuse me, trying to form trunk links, but on 3560, it is static, or the dynamic auto, so they think it's access ports. But what we've got here is an issue because the native VLAN, it's going to come up and say that there's a mismatch. And so we're going to fix that here in just a second on this multi-layer switch. And so here's what we're going to do. We're going to go into the 3 ports, do show IP interface brief. And this is going to be interesting because I'm going to have to double check. So let's get into fast Ethernet 024. And we're going to say switch port mode access, and then switch port access VLAN 99. Now, it doesn't exist, but it's going to be created here on the multi-layer switch. Right? And you see we have the orange dot there, so spanning tree, we're going to be waiting about 30 to 45 seconds. That orange dot will go away. And then let's get into interface gigabit Ethernet 01. We'll say switch port mode access, and then switch port access VLAN 10. And then we'll get into gigabit Ethernet 02, and we'll say switch port mode access, switch port access VLAN 20. And even if I say spanning tree port fast, you'll notice, well, on that one, it looks like it may be an order of operations issue because the port fast in some cases is not working. All right, so let's save our config here. All right, so we've got our VLANs created, right? So now we're going to look at the SVI use case for a layer 3 switch. And that's to perform inter-VLAN routing. Now, could we use it to manage the switch, do in-band management with Telnet or SSH? You absolutely can do that, which is why you typically will create some ACLs. You'll apply those ACLs to the VTY line so that you're only allowing the device to be managed from the network in question. So let's do the SVIs here on the multi-layer switch. So interface VLAN 10. Now remember, the IP address, this is the default gateway address because this is a multi-layer, a layer 3 switch, which is capable of routing the traffic. So now we're going to go ahead and put this in there. So here is the default gateway. So now let's come back to PCA and let's see, can I still ping? Oh, I didn't want to SSH, sorry about that. So can I still ping the switch? Absolutely, I can ping the switch. Now, more importantly, can I ping my default gateway, which is the switch virtual interface on the multi-layer switch? And take a look at that. It works beautifully. So let's do the same thing on the multi-layer switch for VLAN 20. So we're going to go ahead and say interface VLAN 20, and we're going to say IP address 192.168.20.254. Because again, this is going to be the default gateway for all the PCs and switch 3 down here, right? This switch virtual interface up here, because it can do inter-VLAN routing, will be the default gateway. Again, it's just think of it as like a virtual interface on the device that we're sending our traffic to when it's going toward a network that we are not directly connected to, and we have no other option but to just give it to the default gateway and let it handle the routing of that traffic. So from PCC, can I ping my default gateway, 192.168.20.254? And yes, we can. Oops, sorry, I didn't mean to drag that off the screen like that. And so finally, let's go ahead and set up interface VLAN 99. IP address 192.168.99.254. And PCB, can it ping its default gateway, which is that switch virtual interface on the layer 3 switch. And it works like a champ. So here's where we now get into the scenario of the real purpose for the SVI on a layer 3 multi-layer switch. And that is inter-VLAN routing. The capability to get traffic from VLAN 10 to VLAN 99, or from VLAN 20 to VLAN 10, or to route between all of these VLANs. Because watch what happens on the PC when I try to ping 192.168.20.10. That's PCC's IP address. And I can hover over PCC and we can double check. And let me click in there and hover over, and you can see it's 192.168.20.10. But it's not going to work, right? And the same thing is true if I came to PCB and I try to ping, let's ping PCA 192.168.10.10. Excuse me. It's not going to work because we're missing a command up here on this multi-layer switch, because you can use a layer 3 switch as a layer 2 device if you wanted to, right? And this is the option that Cisco gives. This is why this is not on by default. Because if you buy the layer 3 switch, and maybe you're planning one day to do Inter-VLAN routing using it, but right now you're really not, right? You have to enable the Inter-VLAN routing. And to do that, it's very simple. That command that I ran earlier, IP routing, you can now see that this device, a layer 3 multi-layer switch, excuse me, and that's the command IP routing. As soon as I hit enter, all of the switch virtual interfaces I've configured on this multi-layer layer 3 switch, they are now able to route between those VLANs for which a switch virtual interface exists. So now watch what happens when I try to ping PCC. It works because the traffic gets up here to the default gateway, the switch virtual interface on the multi-layer switch, and it knows, hey, I'm connected to VLAN, excuse me, I know I have a network for 192.168.20, which is VLAN 20. Or, hey, I have a network for 192.168.99.10, and I can route that traffic, and the same is true here. What didn't work before now works because this is a router now. As soon as I type in IP routing, I have Inter-VLAN routing, and that is exactly how that works. And that is the use case for the SVI on a layer 3 switch. Now, can I do remote management? Absolutely. And the next conversation that you're probably having with yourself is, well, what if I don't want the management VLAN to communicate with HR, or HR to communicate with management, or I don't want them to access the SVI for the management VLAN? Those are all good questions, and questions that'll come up as we make our way through the course. Let's try one last thing here. On the management PC, what if I say SSH-L admin, and I try to get to the 192.168.10.150? Well, take a look at that. I can remotely manage that switch from this PC because PCB is not connected to that network. And let me type admin in here. PCB is not connected to the 192.168.10, but it has a default gateway. So it knows that I'm going to send my traffic to my default gateway, which is the multi-layer switch. And there's an SVI up here. And Inter-VLAN routing is enabled with the IP routing command. So when that traffic gets to the multi-layer switch, it sends the traffic down here because it knows how to get there. It has an interface in that VLAN, so it will have connectivity. And we have the default gateway statement on here as well, which we configured, and I can't remember where we configured that, right here. And so for the return traffic, it knows how to get back to the multi-layer switch. And then the multi-layer switch handles the movement of the packets. Because watch what happens if I try to do this. If I come in here and I say, let's exit out of here first, SSH-L admin, what happens if I try to get to the switch on PCCs, the engineering VLAN, VLAN 20? Now, we never configured the crypto key, but the problem would be is we don't have a default gateway. You can see connection timed out, remote host not responding. And even if we had the SSH, the keys generated, and we had the user created, and we had the VTY lines configured, it would not work if there's no IP default gateway statement on this switch. So show run include default, it's not here. So if I was to come in here and say IP domain name, ccie.com, and then say crypto key generate RSA, and we'll just go 1024, and then say username admin, and I'll just say password admin, keep it short, and then line VTY 0 to 15, and say login local, and then say transport input SSH. And again, the transport default is transport input all. I'm just typing that real quickly so that you can see. You'd say transport input SSH. So all these things are configured, right? And I should be able to get onto that switch from PCB. But it's not going to happen because the traffic is getting here. It just doesn't know how to get back because the switch, this is control plane traffic. And the switch is trying to send send the traffic back for the TCP three-way handshake, and it's not going to work. It won't work until we give the switch a default gateway and point it toward its default gateway for the SVI that it currently has configured, which is for VLAN 20. So now when I come over to PCB, look at that. Now the switch knows what to do with that traffic. It knows how to get back, right, to its default gateway because we've told the switch. All right, well, that is going to do it for this packet tracer supplemental tutorial and video on use cases for the switch virtual interface. I hope this has cleared up any confusion that you had. If not, please let me know. And that's all I've got. So as always, thanks for watching, and I hope to see you in the next video.